Darlington pair. Okay, so this is again a cascaded connection of two bipolar junction transistor, and it is also called as a super beta transistor, and the connection is shown here. So it is all these topics come under cascading of common emitter amplifiers. So Darlington pair is a very popular connection of two common emitter amplifiers, and the main function is that you are going to have enormous current gain. When you are going to connect the transistors in a Darlington pair connection, the current gain is multiplied. So see, this is a Darlington pair. So you see you have one transistor, the collectors of both transistors are connected together, and the emitter of one transistor is connected to the base of second transistor. So this connection is called as a Darlington pair. So the in Darlington pair, please remember the collectors are tied up together, and you give input to first transistor. The output from first transistor is taken from emitter, and it is given as input to the second transistor. And the output of second transistor is taken from the collector. So this transistor configuration is called as Darlington pair. So I can replace these two transistors by a single transistor, and I'm going to represent it by QD. The Q1 and Q2 are individual NPN transistors. When I put QD, it is a Darlington pair configuration. And the main advantage of Darlington pair is the current gain is multiplied. See, in this common emitter, you have a current gain beta 1. In this common emitter, you have a current gain beta 2. So in Darlington pair, the current gain is going to be beta 1 into beta 2. So enormous current gain is possible by the multiplication current gains will take place since you are going to connect these transistors in a Darlington pair configuration. Okay, so you see here that is what is given here. It is a single unit with the current gain product of individual transistors. So usually we told, right, in common emitter amplifiers, when you connect all the transistors in cascade, the voltage gain will be multiplied. In Darlington pair configuration, the current gain is multiplied. Please relate and study. Okay, so if beta 1 is the gain of the current gain of first transistor and beta 2 is the current gain of second transistor, then the Darlington pair will provide a current gain of beta D equal to beta 1 into beta 2. So the derivation, how we are getting beta 1 into beta 2 is not, it's out of scope for us. So we know what is a Darlington pair connection and what is the effect of connecting the two transistors in Darlington pair. So the two transistors are exactly matching. If I take beta 1 equal to beta 2 equal to beta, then the Darlington pair connection will provide a gain of beta D equal to beta square, because beta 1 is also beta, beta 2 is also beta. So when transistors are having very high current gain are considered as Darlington pair, the overall current gain becomes very high. The certain applications require very high current. Certain applications require very high voltage. So this Darlington pair is specifically designed for those applications where the requirement is a very large current coming out from the amplifier. So if, for example, if the transistor has a current gain beta of 400, then the Darlington pair will have a current gain of 400 into 400, which is 1,60,000. So see, the current is amplified by 1,60,000 times. So the input current is X, the output current is 1,60,000. So such high amount of current is possible when you connect the two transistors as a Darlington pair configuration. So it is available in IC packages. So you need not connect these transistors manually. Already it will be fabricated as an IC, and you will have like a chip. So only three terminals will be visible: base, emitter, and collector of a Darlington pair. So you can connect the appropriate power supply biasing resistors, and you can take the output from the collector of the whatever terminal is visible to you. So this Darlington pair, it is available as a single IC. So inside the IC, you will have these two transistors connected this way. So I can replace this configuration by a single transistor QD. Okay, whenever you have this notation Q hyphen capital Q suffix capital D, you should ensure that you should consider this as a Darlington pair configuration. So Darlington pair is commonly used in emitter follower circuit. This gives an equivalent circuit of two emitter followers in cascade, thereby increasing the input impedance. It is just like your common collector amplifier. So here, the emitter of the two transistors are not grounded, right? So I am taking the output from the emitter of Q1 and I'm going to give the output to a base of Q2. So the first one is a CC, common collector. Only in common collector, input is base, output is emitter, and collectors I'm going to short circuit. So this is also another CC. So this is Darlington pair is going to be two common emitter circuits in two common collector circuits in cascade. Common collector circuit is otherwise called by a name called as emitter follower. So remember, Darlington pair is not CE amplifier, it is CC. So I'm going to have two CC amplifiers in cascade. Okay, the another name for CC amplifier is emitter follower, and the advantage of CC is it will have very high input impedance, which is also an advantage for me. I told you whenever the input impedance of the amplifier is larger, it is going to draw very less current from the source. The source is not disturbed. So when you see that aspect, I'm going to I'm going to have a very large input impedance. Okay, and current gain is also excellent, and this common collector amplifier cannot be used for voltage amplification. So we are using that for current amplification. For voltage amplification, only CB and CE are used. But if I want application where current has to be amplified enormously, I'm going to use the CC configuration, which is called as emitter follower. Since one amplifier is not enough to produce an enormous current gain, I'm going to connect the two common collector amplifiers in cascade. What I'm going to gain as a result of that, the current gain is going to be product. It is going to be multiplied.